Yeah, that's for the filming so it comes out. Otherwise, it gets
shooting with balls, but they'll blind you like a deer. You know.
I've been in places where he didn't film it that are smaller venues, and so the lights will only be like 20 feet away, and I just wear my sunglasses on it. I can't see.
Wear some shades.
Yeah, no, absolutely. No, totally.
You got them on.
My Sunday people got them on anyway because they're all hungover. So. 10 seconds. All right, grab a seat. Get close and cuddly with your neighbor again. We're going to start this thing up. Periodically, we'll be having giveaways at the start of talks for those that are paying attention. But this talk, we don't have a giveaway. I'm sorry. Oh, boo. I brought you some snow. Is it yellow? Yes. Yes. Giving that away. Oh, we're giving away the free mints from the hotel, because it may come to that before cannibalism. Anyway, all right, so we're ready to move on to our first one-track mind talk. Colin Brack's here. He's going to talk about GPU and CPUs and their ability to do cool security stuff and make your head a real chick magnet. So, did you make that graphic yourself?
Oh, yeah.
Oh, yeah. It shows. It's some good work. Anyway, Colin Brack.
Thanks, Bruce. So are we live streaming? Okay. I've always wanted to say, Shmoocon is filmed before a live studio audience, which is very true. Okay, so today we're going to be talking about the CPU, GPU shootout. Everybody here is well aware of the power of the GPU. But first I just want to say it's great to go first because, I mean, logically, no one's going to waste their shmoo balls at the first speaker, right? I mean, come on. I mean, you've got an entire 3 days. But I am, it's going to be bad because I am quite the newbie. And my computer is frozen at a hacker conference. So that is all the more reason. No, just like. There we go. Okay. No, the newbie alert is that I've been out of the InfoSec hacker community for about 8 years. And I've been in academia, where honestly I've been quite disenfranchised with the whole academic process with the universities, with them being really cutting edge where I mean, all the science and technology is occurring. And I thought, what better way to get back into the community by giving a speech to about 1,000 people that are quite more intelligent than I am. So that's what I'm doing today, but I'm down because the hacker ethos is what I genuinely believe in. And specifically, the educational model that the hacker philosophy has adopted for years, and that's truly the, like open source education and freedom of information. I mean y'all popularized that way before OpenCourseWare and all of these other kind of fancy things that MIT and some of the other universities are doing with podcasts and free videos and making the information inside the walls of the university available. I mean, that's been commonplace within this community for years. And so that's my real fascination. And this quote really captured it when I was preparing the talk. Paul Graham, he says, because hackers are more makers than scientists, the right place to look for metaphors is not in the sciences, but among other kinds of makers. And so I truly consider myself a maker. I mean, education is pretty useless unless it results in something like this conference right now. It's an amazing feat that Bruce has made, and what Johnny's doing with Hackers for Charities. I mean, it's an amazing, tangible deliverable, and my 4-year-old kind of nailed it a few weeks ago. I was doing my 10-year reunion in Mississippi at my old college. And so I'm driving up to the parking lot, and I'm telling my 4-year-old, I'm like, Luke, this is Daddy's school, just like, you're in school. I'm just trying to, just let him know we're all in the same boat together. And he goes, Dad, what did you make? And I was kind of taken aback. I wasn't really understanding what he was getting at. He goes, Daddy, what'd you make at school? And I was like, oh, this is amazing. My 4-year-old, he thinks the entire purpose of going to school is to make things. I mean, that's just so pure and so awesome. I mean, in pre-K, he comes home with cool stuff that he's made. I mean, he's made instruments and macaroni necklaces and crazy stuff. And I think for a large part, we've forgotten that. And then my wife wisecracked. She goes, well, I'll tell you what he didn't make. He didn't make a 4.0. And I was like, okay. It's like, thank you very much. I said, that's right. I did not make a 4.0 because I was busy making the school newspaper and making the entire computer lab into a giant distributed .NET RSA cracking machine. So that's what I was busy doing instead of, getting the little perfect grade. So let's segue into the CPU, GPU, or really just the GPU marketplace. It's very crowded right now. I mean, CUDA is really dominated the scene. That's my bias because that's the kind of clusters that I build in healthcare. And ATI was actually the first on the scene in 2005. They had some kind of goofy transcoding tool buried inside the Catalyst drivers. And it didn't get a lot of good press. I mean, they're visionary in introducing it first, but they didn't really continue on that pathway the same way NVIDIA did, really pushing the envelope and really highlighting the educational framework with CUDA. And then you've got OpenCL, which, I mean, think kind of like OpenGL. It's the non-proprietary, unified, heterogeneous platform that combines the CPU and the GPU so you can code for both. And then you've got the gaming consoles actually showing up on the scene and doing remarkably well. So much so that, did you hear about this? The Air Force solicited a bid to buy 2,200 PlayStation 3s for some, I think it was like meteorologic analysis or something. And then I followed up on that, and sure enough, they did buy 2,200 PlayStation 3s for the bargain price of $663,000. So that's good tax money at work there. But I mean, the gaming consoles are a force to be reckoned with. And they're subsidized because, they expect you to buy games, but not in this case. And then the academic community kind of brings all this together in the term GPU, which is just general purpose GPU computing. It's basically using a GPU to do CPU type things. So that's the moniker they use in publications and stuff. So this is the card that I have, the C1060, and you see here on this. They call them these streaming processor cores. Back in the day, these were called shaders, and so that was one of the little stats that you would judge the quality of the card. And now those are basically used as independent programmable cores or streaming cores, and that's why ATI calls them the ATI Stream platform. It's basically a 295, a GTX 295 with just a crap ton of memory. It's amazing. You can get 4 gigs on that thing, and then they now have a 1U device that is basically 4 of those cards sandwiched together, and that's, the marketing speak is a little bit left to be desired, but they say 4 teraflops in a 1U case. So we're working with that right now in healthcare. And so if you think this might be like a brand new, exciting, cutting-edge stuff, and I did a little bit of history and actually came across this project, the Cypherflow project, and these guys were basically taking, when do you think this was done? I mean, by the graphics are probably giving it away a little bit with some sweet HTML there, but this was done back in 1998, and these guys were basically using a custom graphics card that had, how many did it have? There it is on this. Yeah, 150,000 8-bit processors at 100 megahertz. They could custom program those to brute force 40-bit Unix passwords. And that was back in 1998 with this custom graphics board from UNC. in part of their results, they're saying, it's missing some instructions, it needs a little work, but, this is amazing stuff. So this is not new at all. And in fact, this kind of reminds me of this quote from Cray. If you're plowing a field, what would you rather use, 2 strong oxen or 1,024 chickens? Really, it's the power of, that little test case didn't really capture it, but it's the power of more and programming in a parallel environment very early on in your development. I like the whole concept of that 1024, like 1 kilo chicken. It's pretty cool. I read it 2 or 3 times. I was like, that's 1024. That's smart. So who here's done distributed.net? Okay, it's probably the most popular distributed RSA cracking project ever. This is what whet my appetite in cryptography early on in college. And I don't know what's up with this fancy new logo, but this is how I remember distributed.net, which is bovine power right there. And so what I did is, I was doing this back in 2000 when I think they were working on the RC, what was it? Yeah, the RC564 key. It took them 5 years to decipher that into the actual text. Some things are better left unread. And so I spent, my entire college distributed kind of computing career just looking for that phrase. The project finished afterwards, but look at the stats on what these guys are doing. They took the old RC5 client and they recoded it for the ATI stream. For the 4890, this thing can do 728 million keys per second. Okay, so now at first I was like, that sounds like a lot, but I wanted to really benchmark that against what I did in college back in 2002. So I went and dug up my stats at distributed. It's amazing these guys still have the stats. Completely awesome. In fact, I forgot what my email address was back then. I'm sorry, yes, that is an AOL email address, but I found my stats. I was like, okay. I computed 224 trillion keys over 3 years. That was my contribution to the project. How long would that take with 1 ATI card today? So I ran the numbers, and it would take 3 days. And so I was like, wow, that was so useless. But it wasn't. It's foundational. These are the kind of things, these projects, foundationally, that build up to what we have today with this amazing GPU platform. And then I'm sure some of you have seen this floating around academia. This is the 768-bit RSA. It was actually factored. They didn't use GPUs, but I had to just throw this in there for cryptography's sake. And they're basically saying, yeah, 512 RSA a decade ago was factored. Today we're doing 768. Let's get ready and start phasing out 1024. So you just have to start thinking, in these kind of paradigms. And these are the findings of the paper, by the way. If you can't tell, these are prime. I'll give you all a second to just digest it. That's so cool. Okay, what I really like about the NVIDIA platform is that it's this bizarre symbiotic relationship with their marketing department and academia, where they've really infused academia with all these cool kind of showcasing tools. So all these researchers are trying to kind of outdo each other with these little glamorous speed increases. I got 805 times speed up for my flow dynamics algorithm or something. So I really welcome that. I think it's amazing. And then on top of that, they've provided an amazing educational framework where you can download an entire CUDA GPU development course that's been archived on video. There's no lacking in tools, and I think that's what shines with NVIDIA. Okay, so let's talk about some of the tools available to this community, and I'm going to go ahead and I stumbled upon this this manual by Pure Hate, and just want to go ahead and first just let everyone know this is an amazing manual that covers everything and more in this talk. So go seek this out. It's actually on the Backtrack, the new Backtrack homepage. He's the real CUDA expert. I went through the entire manual. This is just some of the findings. Aircrack NG CUDA, you have to get it from the Subversion repositories, but it does compile and is having some amazing speed increases, about 3 times. Just a quick note, it's kind of difficult to build Aircrack. It didn't work for me, so come find me afterwards if you're actively trying to work on the live distro. Let's see, CRARK, that's a RAR cracking tool, 15x speed up for that. GPU MD5 crack, it's unique in that it uses both the CPU and the GPU, so it's kind of that OpenCL type paradigm. It's available on the Backtrack. I think you can app to get that, yeah. It's available on the Backtrack DVD as well. It also does multi-GPU, so if you have like an SLI setup or 2 or 3 cards, it'll take advantage of all of those. The latest in his news was 300 million MD5 hashes per second is in the next version. Ivan Golubev, he has 2 amazing tools that are GPU-based, the IG Hash GPU and RAR GPU. Those are not in the Backtrack distro, but you can find those online. He has support for ATI and CUDA, so he's developing on both platforms. The RAR GPU is showing a 20 times and speed up over NVIDIA, so I think that's reflective of the latest ATI cards just being amazing. At Alexandrovich's website, so for Bars WF, he's got a little breakdown, about a 3 times increase over the CPU version, but he's also outshining pretty much everyone else that's doing MD5. And then exclusively for Windows, you've got Rainbow Crack, but they also have GPU optimized version. And I wanted to leave this one for last because Pyrite, it's showing about a 10x increase, but it's also unique. He has the Stream, the CUDA version, and an OpenCL version. So I mean, I think he alone in this community is cutting edge on the developmental works and using all of those platforms. It's really amazing. Here's his speed increases. You can see this is like what I have at the hospital, one of those 1U devices. And I've got a system that has 3 260s. I thought that was fast, but not anymore these days. And just kind of basic benchmarking with 3 260s, this is just right out of a DVD boot on Backtrack 4 in the live persistent one. You can be up and running in literally, I mean, in just a few hours. So you just apt-get the NVIDIA driver, you apt-get whatever tool you need, and I was showing 31,000 PMKs per second. So this is really just scratching the surface. I'm hoping that some of the talks really go into detail as to how the developers have embraced the GPU platform, and just kind of wanted to whet the appetite for everybody here. Thanks, appreciate it. You have Q&A? We might have just like 1 or 2 minutes for Q&A. Yeah, like 1 minute. 1 minute, okay. How about just one schmooball? I mean, I'm so upset that I didn't, I mean. This is, I'm going to schmoo aside here. Say what?
Why does healthcare need all that horsepower?
We're doing medical physics simulations, so this is just kind of in the research community. So, and it was funny, I had to convince my boss, like remember Envision? They had this kind of NVIDIA throwdown in California. I told him, I was like, oh, I'm going to go and find out about the power of the GPU. And he's like, this is just a subtle attempt to go to a video game world record contest. They were trying to break the world record of the LAN party size. And I was like, no, this is the latest and greatest. And he did not pay for me to go or anything, so I just went anyway and brought back all these amazing stuff that researchers are doing. And he was like, oh, it is true. You can't. And so when we bought the Tesla cards, that 1U device, the thing that sucks about it is it has no video output. I was going to so dual boot that thing and just like go crazy on some video game, but they already thought of that. Okay, well that's a wrap.